Okay, division. We are taking a fraction and dividing it by a fraction. And we've talked about this already this year. Instead of dividing by a fraction, what do you do? Instead of dividing by a fraction, you can multiply by its reciprocal. Well, that means the same thing. So instead of dividing by a number, we multiply by its reciprocal. We've already learned how to multiply. So today we will be changing division into multiplication and then multiplying. So it's like what we already learned how to do. But there is one tiny little thing about those exclusions we need to go over. So what I personally think is the easiest to do is factor first. Before you do anything else, factor. So you are going to factor this, and I am calling on people. 7x factored is 7 times x, just in case you needed to know. Factor it. I want you to factor it. Then I'm going to call people. That's not good. I said, by the way, tell them how to factor that. The other 3 you can grab. And I'm sure we've talked about this a bunch of times in here already, but I say it all the time. You guys know what this symbol means, right? It's a fraction. That's a number divided by another number. That's a dot over a dot. It's a fraction symbol. That's what a fraction bar means. It means division.
Yeah, and it just makes me never.
Are you talking about the 2 buttons? Oh, okay. All right. Tim, you got 2x minus 10 factored. What'd you get? Perfect. Reed, you got x squared minus 6x.
X parentheses x minus 6.
Perfect. Aiden, you got x squared minus 11 x plus 30. Okay, well help me out. Let's do it together. What kind of factoring do you do for trinomial?
2 parentheses.
2 parentheses.
X minus 1.
So make 30. Does it add to give you 11? Perfect. Okay, so we have it factored. Now we're going to think about those restrictions, because anything in the denominator, any x in the denominator that forces the denominator to change into 0, we cannot use. That's a domain restriction. So at this point, what you were doing last time, at this point, what domain restrictions do I have? I have x cannot equal 5. The 2 doesn't matter, because there's no x there. X over here also cannot equal 5, so I've already written in, I don't need to write it twice. What can x not equal right here? So x cannot equal 6. So there's just some restrictions that we have. Then, our next step is we are not going to use it as division. We're going to change it into multiplication. You always keep the same fraction to start, and you flip, you reciprocate the one after the symbol. So I'll reciprocate, I'll get x minus 5, x minus 6, over x multiplied by x minus 6. And then we are going to change our, check our domain restrictions again. Are there any new domain restrictions I have not written down yet? This one is x does not equal 5. What's this one? That's a new one. X does not equal 0. So x cannot equal 0 either. And then for this one right here, x does not equal 6, that one we've already written down. So those are the 3 domain restrictions before we cancel anything. Now we cancel. Tyler, what can I cancel? X subtract 6, okay. Anything else? Mm-hmm. Anything else? The x's, yep. Oh, I'm sorry, I forgot to multiply. Let me multiply. There you go, I multiplied it. Now we can cancel, right? Okay, so then we write what's left over. Let's see, what do we have left over on top? 7. And then on the bottom, 2. Now when I look at my denominator, do I have any restrictions on x's on the denominator in my answer? No. So there are some changes that happened. We need to include everything that changed. So I need to write with it x does not equal 5, x does not equal 6, and x does not equal 0. So that would be our full answer. Right here.
Oh, okay.
So you have to look in the denominator of the beginning, and you have to look in the denominator after you flip it.
Okay. And if it's just an x.
If it's just an x, it'll be like x does not equal 0. Just like you'd say x minus 6 does not equal 0, and then you solve that and say x does not equal 6. All right, next one. What is our first step? Do it. Factor it. I'll be calling on you. This is also an exercise in problem solving and perseverance. Figure it out. Do it. Don't just sit there and say, oh, it's a problem, I can't do it. Factor it. X times x. So that gives you 6 x squared. We need some numbers in there as well. So we are factoring by guess and check. First step is factor. First step is factor. Okay, so you cannot pull the x out because it's not in all 3 terms. You can't pull the 6 out. It's not in all 3 terms. So you have to have numbers in front of the x so that when you multiply together, you get 6 x squared. See inside your parentheses. Remember, this is called guess and check. In order to guess and check, you actually have to guess something. You can't just wait. It's not called wait till your friend tells you. It's called guess and check it. Did I tell you guys we would be factoring the whole year? That and transformation. Well, I know I said it. But you need to write down like the main restrictions before you flip it. Oh. And then work again after. Okay, so I know it's going to have 2 parentheses here. What are my choices for the first spot? What multiplies, I'm sorry, I'm calling them. Duncan, what multiplies together to give us 6x squared?
3x times 2x.
Is that the only option?
No.
What else could work?
6 times 1.
6x times 1. So you've got choices. You have to guess and check. Did you find the answer? Did you get the final answer? Did you get that? Did you get it? A lot of you have 3x and 2x, but then you didn't get past that. Okay, well, what are my choices for minus 15? Okay. 5 and 3, is that the only choices? What was my other choices? 15 and 1. So we have some choices, but somehow we need to put the numbers in that when you boil it back together, the inside and outside add together to give us 1.
3x plus 5.
You got it? 3x plus 5. And then 2x minus 3. So then you check your answer, you multiply together the outside and we get negative 9x. You multiply together the inside and we get plus 10x. And you say negative 9x plus 10x, that is 1x. I captured it. All right. David, do you have this guy factored?
X parentheses 3x plus 9.
Good. So that was a GCS factoring. And then I put that over 1 because when we are multiplying fractions or dividing, we need both of them to be fractions. So now we check to see if we have any restrictions. Domain restrictions. Over here, I've got some x's in the denominator. So you set it not equal to 0. X cannot equal 0. Over here, I don't have any x's in the denominator. So that's my only restriction so far. Now we can change it to multiplication. So we'll still write the same. 3x plus 5 times 2x minus 3 over. And you don't have to factor 4x squared, by the way. I'm just doing it for those of us that have trouble seeing how these things cancel. You could leave it as 4x squared. Okay, at this point, I now have a new denominator, so I need to write down any domain restrictions here. So this first one, x, does not equal 0, I've already written down. But the second one, 3x plus 5 cannot equal 0. That means that 3x cannot equal negative 5. That means that x cannot equal what? You divide both sides by 3. You say x cannot equal negative 5 thirds. You're just solving that parenthesis for not equal to 0. All right, so now we're going to multiply. You get out your magic multiplying crayon, pencil, and you multiply them together. Woo! Did it. Now does anything cancel? The 3x plus 5. Can I cancel one of these x's with one of those x's? Why not? Yeah, they're both in the denominator. It'd have to be one on top, one on the bottom to cancel, so those don't cancel. So we'll go ahead and write our answer as 2x minus 3 over, and then I'm going to have to combine those back together, 4x to the third. Oh, and that's it. I didn't screw it over, but that would be it. Now I check my domain restrictions one more time. X does not equal 0 is my only domain restriction in the end, so what do I need to add to my answer? X does not equal negative 5 thirds. So it's the same procedure as multiplication. You just have to check the domain restrictions before you flip it as well as after you flip it, because we'll have two different denominators to check with. That's the only difference. So if you did your homework last night by yourself, it should be pretty easy to do. Let's just do this number 9, and then we'll work on our assignment. Number 9. Just go ahead and try it. Just where's that? I know I didn't have to do this first term because how did I get 3 into your gift? So how did you know to try to make it? Yes. So to begin with, I picked numbers that were purposely made that. No, I mean, you chose it, you just guessed. You're right, you just guessed it, but there's only 2 choices for here. So I didn't have to multiply these 2 back together because I already knew that those were what those numbers were. It's the middle that I wasn't sure about. But you can totally multiply it all just to be sure. Yeah. Yes, to you. So that would be like up here, where I had X's down there. That would be X does not equal 0. Because it doesn't have like numbers with it, so just X does not equal 0. Any variable in the denominator counts. Any variable. All right, I'm giving you a hint. There it is. Oops. There it goes. There it goes. Mm-hmm. All right, you're halfway there. What multiplies together to give you 5? That's the only choice. So guess where they go and check it. Through here. Or did you put it over there? Oh, I didn't. Oh, that's good. Got it? All right. So did you figure it out? Did you figure out what goes? Well, you know what goes here. Tell me what goes here. 2x and x. And you know what numbers have to be in the other spot. What has to be in the other spot? 1 and 5. Like, they have to be. So as I'm thinking about placing my numbers, if I put a 5 here, I'm going to multiply these together to give me a 10 and a 1. Am I somehow going to get a 3? If I put a 5 all the way over there, am I somehow going to get a 3 from 10 and 1? So I know my 5 needs to be here, and my 1 needs to be here. So I multiply these back together, I get a 2 and a 5. Which one has to be positive? The 5. Over here we've got GCF. Emma, what did you get for factoring this part, huh?
I got X.
So then we look at our exclusions, and in the denominator, I only have 1 x. That x is by itself, so x cannot equal 0. Now we change it into multiplication. So I've got 2x plus 5 multiplied by x minus 1, or 2 times 3 times x, multiplied by, now to flip that. Do I have any new domain restrictions in the denominator? I have a new one. It's when I flipped it, this one right here, 2x plus 5 cannot equal 0. So 2x cannot equal negative 5. Divide by 2, and I have my new domain restriction, x does not equal negative 5 halves. But this x is still 0. Anything cancel? When we multiply together. There we go, multiplied it. Anything cancel? The 2x plus 5 cancel. And that's it. So we multiply it back together. We have x minus 1 on top. On the bottom, we have 6x to the second power. And then since we canceled out that 2x minus 5, that exclusion has to be mentioned in your answer. Negative 5 halves. Okay, let's talk about the worksheet. Let me stop the video.